Here are the rest of our exponent rules. Go ahead and throw your name on here. E.2 notes were called exponent properties of multiplication. These are called exponent properties of division, okay? A lot of them are going to be kind of the exact opposite of the ones that we learned of multiplication. Well, one of them is. And then the other ones deal with what happens when you get a negative exponent, what happens when you get an exponent of 0. So, this is the same. An exponent is the number of times a base is multiplied by itself, and a base can be a number, a variable, or both. We're going to expand out this guy. So this is x to the 5th over x to the 3rd. So use this as like a fraction bar. What does x to the 5th mean? 5 x's. 1, 2, 3, 4, 5. So x times x times x 5 times. Okay. So that's the top of my fraction. That's me expanding out x to the 5th. What does x to the 3rd mean? 3 of them. X times x times x. All right. When you have everything being multiplied and everything being multiplied, we can essentially cancel out something that's divided by itself when it's just multiplication and just multiplication. You can't always, with a fraction, just cross things out. But since it's just multiplication on top and just multiplication on bottom, we're able to cancel out 3 sets of these x's. The reason why, what is x divided by x? What's anything divided by itself? What's 10 divided by 10? 1. 30 divided by 30? 1. So x divided by x is 1. So we can essentially reduce out 3 of these sets. So cross out 3 of those sets of x's. Hey, so now that I've canceled out 3 sets of x's, what do I have left? 2. So I've got x to the 2nd power. All right, we're going to expand out one more. This one, we've got some numbers, some coefficients, and then we also have some m's and some n's. We've got 15 m to the 3rd, so 3 of those. 1, 2, 3. And then I have n to the 3rd, so 1, 2, 3. Okay. Any questions on my expansion on the top? Okay, then on the bottom, I have a 5. And then I have an m by itself. I'm going to go ahead and put my first power on there. It's going to help me. So I have m. And then I've got 2 n's. N, n. Hey, what can I cancel here? 2 n's. So let's start from the right over here. Let's cancel 2 sets of n's. Okay. Can I cancel any m's? How many sets? Just 1. So just 1 set of m's. All right. Then, let's think about that 15 and that 5. They are just normal numbers. So yesterday, just like how we multiplied normal numbers, today we're going to divide normal numbers. What is 15 divided by 5? 3. So I just have a 3. And then I've got m squared, and then just 1 n. I can put a first power there if I want. It's up to you. All right. So, take a second, just like we did yesterday, and by yesterday I mean Tuesday, to look at your exponents here and here. Look at your exponents here and here, and see if you can see the pattern. So take a second to think about it. Okay. Now, take a second to talk to the people around you. See if you agree with them. What are you doing with those exponents? Okay. What operation can we do with those exponents? Subtract them. So this is the quotient rule. To divide powers with the same base, you can just subtract the exponents. Okay. Yesterday, we learned the product rule. To multiply when we have the same base, what did we do? Add the exponents. Opposite of product is quotient. Opposite of add is subtract. So it makes sense that those rules are like the same rule but opposite. Okay? So quotient rule. To divide powers with the same base, you can subtract the exponent. So right here, instead of expanding, 5 minus 3 is 2. 15 divided by 5, we just divide it out normally. And then 3 minus 1 is 2. 3 minus 2 is 1. Any questions about that? Okay, now that we have the quotient rule, some wonky things are going to happen. So move down. The next example says, use the quotient rule to simplify the following expression. So we just learned the quotient rule. We can subtract our exponents. We've got x to the third over x to the eighth. So we would take our exponents and we would subtract them. What is 3 minus 8? Negative 5. So we now have x to the negative fifth. Okay. We do not like negative exponents. A negative exponent will never be in its most simplified form. You always have to make your exponents positive. So now we are going to do this problem again, x to the third over x to the eighth, but we're going to use expanded form to do it. So x to the third on top is x times x times x. And then x to the eighth on bottom is 8 of those. 1, 2, 3, 4, 5, 6, 7, 8. Okay. How many sets of x's can I cancel? 3. Okay, so I'm going to cancel 1, 2, 3 sets. How many x's do I have left on the bottom? 5. So I've got x to the fifth left on the bottom. What do I have left on the top? What do I have left on the top? How many x's are there on the top? So there are no x's. If I were going to put a coefficient here, what coefficient could I have put? A 1. So we are going to put a 1 on the top of our fraction as a placeholder. We don't want to put a 0 because 0 times x times x times x would have just been 0 on top. X to the third is the same thing as 1x to the third. So anytime you need to add something in as a placeholder, you'll add in a 1, not a 0. Okay, so that means this and this are the same thing. So this right here in this gray arrow is your negative exponent rule. Anytime you have a negative exponent, if it is on the top of a fraction, you can move it to the bottom of a fraction, put a 1 as a placeholder in the top if there's nothing left in the top, and it becomes positive. Or if it's in the bottom of a fraction, you can move it up to the top. This would be over 1. And it becomes positive. So wherever your negative exponent is, you move the base with that same exponent, and then you just make it positive. And you can either move it to the top, from the top of a fraction to a bottom to make it positive, or the bottom of the fraction to the top to make it positive. So anytime you see a negative exponent, you will move the base and the exponent to the other side of a fraction. And if it's not yet a fraction, you'll have to make it a fraction. Okay, and we have examples where we'll do this on the back. Last rule we're learning today. We're going to use the quotient rule to simplify out this guy. So we've got x to the fourth over x to the fourth. When I am dividing, quotient rule tells me I can subtract my exponents. What is 4 minus 4? 0. So I now have x to the power of 0. Okay. Just like having a negative exponent is weird, having an exponent of 0 is weird. So let's expand this one and see if we can figure out what this is equal to. So x to the 4th over x to the 4th. So I'm going to put 4 x's on top and 4 x's on bottom. Okay. How many of those x's can I cancel? All of them. So these cancel, these cancel, these cancel, these cancel. When we cancel something, though, what's x divided by x? 1. So anything divided by itself is 1. So once I cancel all this out, what am I left with? 1. So my answer to this is 1. So this is called the 0 exponent rule. And it is that anything, everything, raised to the power of 0 just equals 1. That's it. Anything to the power of 0 is 1. Okay. So these are our 3 new rules. Quotient rule, we subtract the exponents. Anytime we have a negative exponent, we move it to make it positive. And then anything to the power of 0 is 1. So those are our 3 new rules. Any questions before we use these 3 rules in our examples? Okay, so let's go look at our examples. We have a few more today because there's like just more things that could happen. Okay, we've got x to the 14th over x to the 5th. This is just simple quotient rule. We have the same base, so we just subtract the exponents. So I'm going to do 14 minus 5, which is 9. I get x to the 9th. Okay. My next one, I've got 8n to the negative 7th. What needs to be fixed about this one? What is the thing I need to simplify? We need to deal with that negative exponent. So if that is a negative exponent, how you make a negative exponent positive is you move it to the other side of a fraction bar. Is it currently on the top or the bottom of a fraction? Top, because there is no bottom, okay? So we are going to leave the 8 on top because the 8 doesn't have a negative exponent. And then we're going to make a bottom of the fraction. We'll move in to the bottom, and now it's positive 7. Okay. Next one we've got 4a to the 7th, b to the negative 4th. What needs to be simplified about that? The negative. Where is b to the negative 4th right now? The bottom, so it gets to move up to the top. The 4 and the a to the 7th can just stay on top, and then b to the 4th moves up with them. You could put that all over 1, but there's no reason to. You don't really need to. Okay. Next one. We have 5x to the 0th. Anything to the power of 0 equals 1. So on this problem, x to the 0 equals 1, but 5 is still 5. So this would be 5 times 1, which we can multiply together, which would be 5. So my answer to that problem is going to be 5. Okay, what's the difference between this problem we just did and this problem? This one's in parentheses. So what is to the power of 0 here? everything. So this one, 5 is to the power of 0 and x is to the power of 0. So since they're both to the power of 0, this one, your answer is just 1. Since it's everything to the power of 0. Okay. My next one, I have 12x to the negative 8th, y to the 11th. Only thing I need to move is my negative exponent, and then it goes with its base. So the 12 and the y to the 11th can stay on top. And then x to the negative 8th can move to the bottom and become x to the positive 8th. All right, any questions? All right, we have 2 more where you're going to use the quotient rule to simplify things out, and then we might have to do some more stuff. So that's what these last 2 are. So on this last one, or the second to last one, let's deal with the 4 over 12 first. 4 divided by 12 is going to give us a decimal. So we're going to reduce that because we don't want a decimal on top. 4 and 12, what can we divide both of those by? Okay, we can divide them both by 2. And so then it'll be 2. If we divide the top by 2 and the bottom by 2, it'll be 2 over 6. Can we reduce 2 over 6 anymore? So yeah, we could divide it by 2 again, or we could have just divided by 4 from the beginning, okay? So if we divide the top by 4, it's going to be 1. If we divide the bottom by 4, it'll be 3. So for our constants, or coefficient, sorry, it's going to be 1/3. So instead of 4/12, it's 1/3. Then we can deal with our exponents. So my j's, I have 2 minus 1. What's 2 minus 1? So I've got j to the first up top. And then my k's, I have 7 minus 9. What's 7 minus 9? Negative 2. So I've got k to the negative 2. So that's where I'm at right now. What'd you say? You got to move the k to the negative 2 to the bottom. So on the top, I've got 1j to the first. I'm just going to put j. I don't need to put 1j. And then on the bottom, I still have my 3, and my k squared is going to move to the bottom and become positive. Okay. I want to show you guys something else you could have done with this one. Instead of doing 2 minus 1 and 7 minus 9, you can kind of use the negative exponent rule and the quotient rule together. And you do 2 minus 1 and put it on top. And then you can see you've got 7 and 9 here. So instead of doing 7 minus 9, which is negative 2, and then having to move it to the bottom, we could have just done 9 minus 7 and then left it on the bottom. So if you use like the upside down, so like quotient rule, if what I said just confused you, I would just do it in 2 steps. But you can think about that and skip over the step if that makes sense. Because if you think I have 7 on top and 9 on bottom, if you like visualize what it would look like if you expanded it, well, I'm going to end up with 2 and they're going to be on bottom. Okay? Last one, I've got 10m to the 7th, n to the 12th. Sorry, n to the 14th. And then 2m to the 1st, n to the 12th. 10 over 2, what's going to happen there? I can divide that out. That divides evenly. 10 divided by 2 is 5. Then on this one, I can subtract my exponents. They'll all end up being positive. 7 minus 1 is 6. 14 minus 12 is 2. Okay. Any questions? Oh, I'm like off the screen, sorry. I didn't realize I had scooted over. Hey, I'm going to stop this video then. Stop the video.